Good morning. This project is one project of the Virtual Square project, Virtual Square team. Virtual Square is a container project, is actually a group which are carrying out several projects. So let me start from the end of the talk saying that if I'm not on time and I have to finish the talk earlier, wiki.virtualsquare.org is the place where you can find all the information and examples and everything. Let us start the other way around. Okay, talking what are the goals of the Virtual Square group? There are several kinds of virtualities in our software. So virtual machine, virtual networks. These are kinds of tiles of a puzzle or Lego blocks, and we want to have to combine all this idea together. So the main goals are communications. So we want different virtual entities to communicate together. Actually, we have different virtual machines, and we cannot make them communicate directly without VOS tools. Integration, so we want to have different virtualities seen as special cases of a broader view about virtuality, and then with this kind of unification between among all the concepts of virtuality, we want to extend this idea of virtuality and designing virtualities. Okay, let us go to the focus. Let us focus on the topic of this talk. VOS, a process with a view. What's a view? Its process in modern operating systems has a view of the world made by the answer given back by system calls. So a process can see the network, can see the file system, can see all the execution environment through the answer it receives from the system call. Actually, currently, there is a usually hidden law in modern operating systems named the global view assumption. It means that it is common that all the processes running on one operating system are sharing the same view, so the same network, the same file system view, in a broader view, the same naming. That's almost true in POSIX system. Almost true for two reasons. There are some exceptions like chroot that changes the view of the file system, or virtual machines that in the reality change completely the view of processes, but they create a new domain in which there is a global view assumption. There are other notable exceptions that are coming, like containers or other stuff in the kernel. System virtual machines, let me say like KEMU, like KVM, PeerPC, require to put an entire operating system. If you want to mount a file system and you are not root, you can start a virtual machine and make the file system mounted by the operating system of the virtual machine. But you need to boot an entire operating system. User mode Linux is a user mode, is a system call virtual machine. So instead of virtualizing the whole hardware, it virtualizes just at the system call level, but it boots an entire Linux operating system. fake root, change root, fuse, systrace, all are tailored to specific application. It is not a broadened view on virtualization. And most important, the major part of these virtualization tools require you to be root to run them. In Unix, in POSIX, you have a global effect of many commands. So if you mount a file system, that file system is mounted for everybody, for all the processes. If you want to protect the file system from undesired accesses, you need to work with permissions. But the fact that that file system is mounted is a global view effect. Or if you change the IP address, the IP address is the IP address of the single stack running on the operating system, which is not a rule given by God to have one stack, to have one single view on the file system. Why a user can't define his, her own virtual private network? So in one session, even one single shell, we want to use a different networking, not the kernel stack. VOS means that. So we have designed the way to have each process given its own view of the world. So mount of the file system, redefinition of access permission, definition of interfaces, IP addresses, networking in general, definition of device, everything can be done at process level. So we redefine the system call behavior, so system call can behave in different manner. We can define even new system call if you need them. And we want to achieve the goal, we have achieved the goal, while maintaining binary compatibility with existing code. So you have not to recompile everything. And the idea is to have a modular system, so you can add and run only the virtualization you need, and you don't need to be root. There are several ways to implement this kind of virtualization. One is a new kernel, but it's unpractical. Either a system called virtual machine, so think to a user mode Linux, but instead of booting an entire kernel, this user mode view, one view, let you load the specific modules for what you want to implement. And the virtualization is partial. So you can have part of the file system which is real that interacts with part of the file system which is virtual, or a kernel module. And we have now a prototype even of a kernel module based on utrace. So let us go on. No, the other way around. So we have one view, runs on vanilla 2.6 kernel. You don't need to patch the kernel too. But if you want, there is a patch to increase performance, but it's not necessary. KMU, on the opposite, need a utrace. Utrace is a support for virtualization made by Roland McGrath from Red Hat. And it is faster than UMView, and it's more transparent. Transparent because UMView is based on ptrace, and ptrace has some limitation. Ptrace, okay. Let me skip this. Okay, let me go to the heart of the presentation. One module of UMView or KMView, the modules are compatible, is UMFuse. So think of Fuse, the kernel. Fuse is inside the kernel, and you have user support for Fuse. This Fuse file system at user level within So, and we have source level compatibility with the module. So if you have a module for encrypted file system, NKFS, you just have to recompile it with our library, and it becomes a user mode fuse module. We have all this module running, X2, ISO, FAT, and we have developed this. And then we have inherited NKFS, SSH, CRM, where we have added audio NDNS. And there is a new module, a prototype FSFS, but I have no time to introduce that. Let us see by hand what else mean. So if you are into a OMView machine at the beginning, nothing changes. You just start a shell, and it seems that you're working with outside OMView. But you can add the OMFuse service, and then you can take a file system image and mount it using the system mount command as a user, and you have mounted this file system. If you go to another shell and you type ls tmpf1, it is empty, or even it doesn't exist, because it's virtual. It's like you have 2 layers of kernel, so the system call coming from the processes, if they're referring to something virtual, are managed by the second layer of kernel. Otherwise, I'll send it to the real kernel. This is a hard work. So we have mounted to show that it can be nested. First, we mount an encrypted file system that contains, we mount a remote file system that contains an encrypted file system that contains an X2 file system. OMDev is similar, but for devices. Let us go here. You can define a device mount as dev HDA as a user. You can partition it, make a file system, and mount a file system. You create a virtual /dev/HDA. Bin format if you want to run a bin FMT in the kernel, the virtual way. And LWP is a complete stack, network stack. W4, W6, it's a neighborhood stack, and you can run. Here we have the real interfaces, and then when we add the module, we have the new interfaces. VD is VDE, our virtual distributed Ethernet network. Is another result of the Virtual Square team. And then I can SSH this machine, and this shell is working on a different stack. Virtual Distributed Ethernet is our virtual network. Appears at a local area network. There are switches that are the counterpart of the real switches. You can create wires between remote switches. For example, you can use SSH as a wire. Okay, read quickly this. We are kernelizing VDE, defining a new family of protocol, inter-process networking, which is something like the family Unix, the Unix socket, but it's multicast. And this we have used this for kernel VDE, but also for MPEG TS stream dispatching. So it's a general tool. So this is a final summary. We have created several tools. All these tools, except from the very new one, are available at SUSEForge and I say Debian. Stop.